I thought you'd probably seen enough of me pushing wheels into muffs, so since the last part I've gone ahead without you and fitted the tender wheels. Before I invest a lot of time in making the valve gear, I want to make sure that this chassis fundamentally works without any of the dangly bits which might cause binding and problems. So what I'm going to do over the course of this part and the next part is fit the motor to the tender chassis and the worm gear to the gear tower and work out what the coupling arrangement is going to be. So I'm going to use one of these flat can motors sold by the association that's going to get araldited directly onto this pivoting platform. But before I get carried away with any of that, I need to test this chassis now as a coupled unit to make sure that it will actually go round corners. So with the tender and chassis coupled together, I'm going to try another version of the tilt test that you saw in the last part. And here I am rolling them through reverse point work. These are very tight points. I think they're A6 points on Clive Road sidings, which is now my test track, originally built many years ago by Mark Fielder and still standing the test of time, has to be said. So here's the worm housing that we built what seems like months and months ago, and I've put a piece of axle steel through there, and onto the end of that axle steel we'll need to fit some kind of universal housing. And the motor, with a thinner diameter shaft, is going to be about this distance apart from it, and some kind of rod is going to be needed to connect the two together. So if we look back at Nigel's loco, I showed you this right in part 1, but we'll just have a look at how it's constructed. And here we've got a sort of thick-walled tube which has been turned on a lathe from brass with a slot up the middle and then a collar put round. And one of these steel wire universal joints will go into the slot, and that's got flexibility to move in different directions as it turns round, so the loco can go around corners and things. Now if you wanted to make one of these without a lathe, what you'd have to do if you wanted to make it from brass is get several different telescoping brass tubes. The outer one you wouldn't slot, the inner 2 or 3 you would slot, and the smallest one would have a diameter up the middle of 1.5 millimeters, and that could then be soldered onto the axle steel that would go through the middle of the worm in the worm housing. An alternative, if you didn't want to use telescoping brass tube, is to use a plain ordinary axle muff, put a slot up the end of that, and then get some brass tube with an inside diameter of 1/8 of an inch or 3 millimeters, depending on whether you're using metric or imperial muff. Araldite that round the edge, and then the muff, half of it could slide on to the end of the axle steel. The other half of it would have the slot in it, so it would slot on like that. So that will be the most straightforward way of making one of this kind of universal coupling without a lathe. Now I must confess I've never actually made one of these slotted universal joints. I usually make mine out of 7mm scale handrail knobs, these little things. Now, I generally find that I can make the housing for these just that bit smaller and more discreet. So this is what I do to them in my lathe. I turn off the flange and file the top end flat, and with that top end flat I can use a centre drill to mark the centre and then a 0.3mm drill to drill all the way down the middle of these. And that is not an operation for the faint-hearted, I can tell you. But once I've done that, I can solder a piece of thick wire through the handrail knob itself, through the hole that was already there, and then insert some thin steel wire up the middle of the hole that I drilled to join them together. And here's an example of one that I've made. It's on a Bob Jones 9F that's still under construction, but you can see here that the wire that's coupling them together is the same steel wire that was used in Nigel's. It's just got a different fitting on the end. The housing is simply a piece of brass tube soldered over the worm shaft with a slot up it, in this instance much longer than it needs to be. And if I turn this round you can see the cross piece there that's soldered through the handrail knob. And I've seen a few etch kits come with an etched version of this universal joint coupling, but of course the Jubilee doesn't have one of those. Now there are commercial universal joint kits available, Brass does one for instance, but they tend to be quite large. But here is the very latest offering from the 2mm Association shop. This is hot off the press. It's a 3D printed universal joint kit, and I'm going to have a go with this. I've never used one before. I don't know what it's going to end up like, or how robust it's going to be, how long it's going to last, but it looks very, very neat. So we need to start by separating the components. You get two universal joints in here, one for each end of the shaft, I guess. Very small, and the idea is that these little pieces fit inside the housing. Or they ping across the desk, whatever you want to do with them. Probably get a firmer grip on these with my fingers. This has actually got sort of 4 little studs, and it's quite a tight push fit in here, and it sort of clicks in and holds itself in place so it's not going to drop out, which is quite nice. There's a hole up the end here. This is about 0.8mm, and the short piece, I don't know if you can see, it's got a little dimple in the end. So whatever we do with these, we're going to have to drill out these holes. And if I bring in one of my brass handrail knob universal joints for a size comparison, you'll see that the size of the ball end is pretty much identical, and the bit that the shaft fastens to is even smaller. So I'm going to have a go at fitting one of these housings onto the motor shaft. As I said, I measured it at 0.8mm. Well, a 0.8mm drill would slide up it. I'm drilling it 0.9. I'm going to have a see if it's a push fit at 0.9 if I can get this up it. And there's no way that's going on there, no matter how hard I push. So I'm going to have another go with a 1mm drill. This actually cuts and drills very nicely. I don't know what material it's printed in. Looks like the Shapeways material formerly known as frosted detail plastic. But with a 1mm drill, it's a tight push fit on this 1mm steel shaft, which is quite good. And I've even managed to drill the hole straight up the middle just in my fingers, so I'm quite pleased with that. When the time comes, I'll need to super glue this onto the shaft. But so far, this is looking nice. Just mentioned this drill set I got from Expo. It's got a lot of drills with 2.4mm shanks that go up in 0.1mm sizes. So for the other shaft, that's 1.5mm, the worm shaft, I mean. So I'm going to have to go up in step sizes. So I'll start with 0.9, then 1, then 1.1, and so on, all the way up to 1.5. I don't want to try going to 1.5 straight away with this, because I might ruin it. So here we go, step by step by step. And as I'm drilling into this, because of the material it's made from, it's slightly transparent. I can see the drill shaft going up the middle, so I can see how far I've drilled in, and that I'm not going to drill all the way through and ruin the bit where the ball end has to click into place. I don't know whether that's a deliberate design feature or a happy accident, but it's very convenient in any case. I'm up to 1.4mm now, just taking a bit more care now to make sure I'm getting this dead straight. And this is the last one. Just a complete random aside here. Many, many years ago I had a tropical fish tank, and at one stage I had some glass fish where they were transparent and you could see all their guts and their organs inside. And for some reason, just sort of drilling up the middle of these 3D printed parts is making me think of those glass fish now. Anyway, back to the locomotive, and this is now a good tight push fit on this 1.5mm axle steel. So now we can see how far the axle is going to protrude into the universal joint housing. We can work out how long we need to make the piece of axle steel that we're going to use for the worm axle. So I'll just measure this roughly lined up on there, and it's going to come out at about 14mm. So we need a piece of axle steel 14mm long, and using the squares of my cutting mat I can put some blue roughly there, and then again with the calipers just put a little scratch on there at 14mm. Probably can't see it there, but if I move in closer you can see the scratch mark. This doesn't need to be absolutely dead on, because there is going to be a bit of end float. So in the vise I shall cut this off very quickly and then dress the end with a file. And once I've removed this from the vise, the end that I've cut off, I'm just going to file to take away any burrs that I've raised by either sawing or filing. The other end, I want a more pronounced chamfer on, so I'm going to use the mini drill, and I'm doing exactly what I did when I made the half axles for the gears, so that chamfer on there will help this axle steel engage within the worm when I put these together, and it's also going to find the second bearing when I put it through. Now, speaking of worms, you might get a different sized worm according to your gears. Here's one that's too short, here's another one that's slightly too long. I think I'm going to use the too long one in this instance because I can just file it down a little bit. I want a tiny bit of sloppiness in here, but not too much really, just a running clearance. If I end up with a gear that's too short and I don't have another one to choose from, then what I can do is I can get some bits of axle muff, chop off some slices of that to make washers, or if it's just a tiny bit too short, I could use some actual washers. But anything to take up that end play so that it just becomes a good running fit, not slopping up and down. So I've filed a bit off this to keep it to length. I'm just holding it in my fingers now. I'm not putting it in my pin vise like I did with the muffs, because I don't want to risk crushing the form of these teeth. But once I've got it the right length, I'm filing a chamfer around carefully, and I'm going to use my drill bit to make a chamfer on the inside. That's going to help it engage on the axle steel. This end just needs a little bit more, and of course I need to do this on both ends. Oops, if I'm not all fingers and thumbs. But it's important, as well as these chamfers, to make sure that this end is smooth and that there are no burrs on it. And once I'm happy with that, I can test fit it inside here. I've just got the tiniest bit of end play, and I'm going to put a 1.4mm drill shank through there and just check that it rotates freely. And that seems okay. If you just see there, that's the amount of end play that I've got. Just a fraction of a millimetre. So now I can put the real axle steel through here. So I need to get this lined up, and here's the rod that I've prepared, and I need to make double sure that it's the end with the chamfer that I'm inserting into here. So that's the plain end. That's definitely the chamfered end. And that goes in and engages with the chamfer in the worm. And I can't push this in, it's a very, very tight fit and it's got to go a long way, so I'm going to have to squeeze this up in my vise. So as I wind this in, I just try and engage it a little bit, and then I need to line up this worm as straight as I can. So I get some tweezers and just manipulate it a little bit so that the holes are lining up with the hole in the bearing, or at least as near as I imagine they can be lining up. So I push this steel in straight and not off to one side. Obviously that chamfer is going to help it go down straight. So it's just a case of slowly winding in the vise now. So I'll speed up this next bit of film because it is a slow job doing this, just feeling it as we go. You see I've got nearly to the end now, and those holes didn't quite line up, so another bit of adjustment. There we go, keep it straight. And then wind it in all the way to the end, and that should feel its way with that chamfer into the bearing at the other end. Fingers crossed. If it doesn't, it'll just stop. Not going to destroy anything doing this. Now, what I need to do now is just put a washer so I can push this further in, because at the moment the axle's coming into the bearing and that little chamfer is in the bearing face, and I want that chamfer to poke through a little bit really. So using the washer to support it, I can squeeze that in further. So if we have a look, this is the kind of fit we're aiming for. And curiously, we've actually ended up with more end play now. As this shaft's gone in, it's kind of like deformed the worm slightly, squashed it out and made it a bit shorter. And as I rotate this now and test that it's free, disaster of disasters, I've got nice end play, and it rotates until it gets to this point, and then it sticks. And this is a serious problem. And what this is telling me, well, it's telling me two things: that the clearance I've got is absolutely zero, and that this hole in the middle of this worm is not actually concentric with the outer surface of the teeth, because there's one part where these teeth are rubbing against the nuts that I soldered on the inside of this worm housing. So I'm going to have to take some remedial action to correct this, because at the moment this is just not going to work at all. It's not a disaster, I can fix it, but it's going to involve some surgery to this worm housing. So having pressed this axle so carefully into the worm, I'm now going to have to press it out again. So I reach for my trusty GW Models Type 2 gear puller. No toolbox should be without one. It should be fairly obvious how this works. You've got a pokey bit that winds in, that pokes the axle down the hole through the gear, which itself is supported by the steel frame, and the shaft itself is ejected through the slot in the bottom. The only difficulty here is because this worm is long and the pokey bit on the end of the screw threaded part of the gear puller is only about half the length, we're going to poke this out halfway and then have to find some other means of getting it out. So there we go. I've gone as far as I can with the gear puller, and I could try then pull this out the rest of the way, but that's not what I wanted to happen. I've actually destroyed the worm housing. Well, it's not destroyed. I've actually rapidly unsoldered that end, and that's not too bad. However, I'm going to have an extension to the pokey bit, and a handy 12BA screw will do the job. So we can put this in and push a bit more, and suddenly the shaft pops out and everything's in bits again. Now, actually, being able to unfold this end is quite fortuitous, because it means we can get inside to these nuts which are too thick with the soldering iron. I reckon you've got 2 or 3 folds and unfolds of half-etched lines on brass kits. But if we look at the gear down there, we can see it's absolutely no clearance. The shaft hole lines up with the bearing, and I could file these down if I wanted to. I'd want to take at least 0.3 of a mil off the height of these nuts. But there is another way, and that's to take these nuts off and replace them with some which are smaller. So you can buy half-height nuts. In fact, the 2mm Association Shop 3 sells half nuts. So there's your standard 12BA nut. It's about 1.2mm thick. And here is a half nut, which is about 0.6mm thick. Well, exactly half, as it happens. And so I'm going to take off these full nuts and replace them with half nuts, and hope there's enough thread on these half nuts to hold the gearbox in place. So, with the ever trusty cocktail stick screwed into the first nut, apply some flux to help things flow around, and then a hot iron, and given a little bit of time, the heat will transfer from this iron. I'm being careful to heat the nut as well as heating the floor of this box, and I'm fairly confident that I'm not going to end up unsoldering the bearings at the same time. So that's first one out, second one's coming out in exactly the same way, and then where this solder has sort of formed a shape around there, just remelt it and flatten it out, so I've got a nice flat surface to put the new nuts on. And exactly as I did when I first made this, I'm going to use cocktail sticks from the outside, screwed in to the nuts, get them down as tight as I can, and then using the cocktail stick as a handle to hold everything, I can put some more solder on here and solder this new nut in place. I built a few of Nigel's kits which have this type of worm housing, and I've never run into this clearance problem before. The Princess Royal class works like this, the LMY 080 works like this, and I just assumed that this would be okay. But that goes to show what making assumptions does for you. Had I been using the metric worm gear set from the Association shop, the problem would have been actually worse, because those worms are slightly fatter than the Imperial ones. They're designed to work at the same meshing distance as the Imperial gear sets, and the wheels themselves are slightly smaller, so the worms were made fatter. I think with these half-height nuts though it would fit inside. There's just a 0.1 or 0.2mm difference. Anyway, we need to solder this end back up now, and in order to do that and make sure everything's in line, I want to put some axle steel in to hold it in place. Unfortunately, my cocktail stick is in the way, so I'm going to have to trim that cocktail stick down. I'll do the other one as well, and then replace them in the nuts to make sure they don't melt and move while I'm doing the soldering at the end. So it's really important that I put this axle steel in place so that these bearings are held in line if I want there to be any hope of the worm shaft being able to rotate once I've done this. So I'm holding them in the vice jaws, and I've got a coffee stirrer here to act as a sort of thermal barrier between the end plate of this component and the vice jaws. Otherwise the vice jaws would act as a heat sink and I'd never solder these things back together. So I'll check that that axle steel rotates freely and can slide freely to tell me that those bearings are truly in line, and then I can start the soldering operation. So I'm just getting it at a jaunty angle so we can see here. Got some solder in this corner and putting in a fair bit of heat and flux so that that solder flows down the joint. Also touch it from the outside as well to try and draw it through. But after some soldering and cleaning up, we are pretty well back to where we started from, none the worse for wear, and it spins nice and freely on the axle. So I think a big whew all round is called for. We've got away with this one. So now we go back a few steps and insert the axle steel into the worm again. Being more confident we can do it quicker this time. And again with the washer, and there we are. And this time it's nice and free. So I just check the fit of this universal joint housing again on here, and that looks good. And then we can move on to the next step of the assembly in the next part.